I was watching today's lecture and have a question about iron.
Yes.
I am aware that iron could be 2 plus, 3, 4, and 6.
Mhm.
Can it go any higher? No, right?
Typically, it doesn't go any higher than 6.
Okay.
At least not that I know of. You can also have iron 1.
Yeah.
But it's again, it's pretty rare.
And it follows the other non-metals, right? So like I was watching like I said, I was watching the lecture and it's I think one of the examples was Fe and it was iodine 3. So
Yeah.
if it's completely blank, then it will have the same. Well, it wouldn't have the same charge, but it will have a positive charge. I don't know.
Yeah, so it always balances it out. Yeah, at the end of the day, it has to add up to 0. We know that iodine, if you have iodine,
Mhm.
you have 3 iodines, then we know that means we're working with iron 3, right?
Does that only is that only with iron, or does it have to do also with the other transitional metals
All
as well?
transitional metals. So it really just depends on who they pair up with.
Oh, okay. Thank
And
you.
so, and that's the thing about the transitional metals, is that the transitional metals, I like to think of them, they're like all my exes. They're all hot messes, right? So I had to tell them who they were, right? I'm the partner. I said, okay, you're going to be +2, right? So then they're +2.
Alrighty. Okay, cool. Thank you.
Okay. Any other questions? Okay, good. So let's see what you guys know. Let me give you the skinny here. So I'm extending your homework until next week because we haven't gone over all of nomenclature, and then this morning class got a little pushback. This afternoon's class got pushed back a little bit. So we're a little bit behind where I want it to be. You have an exam that's going to be coming up. April 23rd is going to be your next exam. And it's going to cover nomenclature. Are you guys ready? Heather, you ready? I know Wilmer's ready.
I'm
No,
putting
it's too soon, Dr. Henry.
I'm putting the date in the calendar.
Okay. So April 23rd, I'll send you guys an email to remind you when it's going to be. So you'll start seeing little pop-ups and stuff like that. It will be covering mostly nomenclature. There'll be a little bit more, of course, all the stuff that we've covered before. And you guys remember that everything that you've done is going to be needed. You got to remember that because it kind of plays on it, plays on itself. Okay. So what was I going to say? So are you guys ready? We'll see those skills. Are there any questions before we get started?
Are you going to go over the metals again? Because I was a little confused on the metals.
Metals?
Yeah.
So what do you mean by that?
Yesterday when I was doing the homework, I was looking into like the Roman numerals. That was kind of throwing me off.
Okay. So let's talk about those Roman numerals. Okay. So hold on one second. Okay, so as I was saying earlier, transitional metals, and these guys down here, all these guys in the middle, these guys, okay? So these guys are always going to be hot messes, right? So they need someone else to define who they are, their charge in that regard, okay? Because they need somebody to define who they are, we're going to have to use who they pair up with to determine the charge that they are. So I gave the example last week of iron 3 iodide. So we know that iodine has what charge?
Has a negative charge, -3 charge.
It has a -3 charge, or it has a,
Oh,
each
I'm sorry,
iodine has a
-1, right?
-1.
Sorry
So
about
we
that.
know that iodine has a -1 charge, and there's 3 of them.
Yes.
We know the rule for ionic compounds is that an ionic compound has to equal 0, right? So then what has to be the charge on iron?
+3.
That's right. That's right. So then we would call this guy iron 3 iodide. Because we know that the IDE means it's a single element, and it is an ion in this case, and it's at the end of the compound. Okay? Did you see that?
Yes.
Okay.
Dr. Henry?
Yes.
So for the transitional metals, so they're always just going to be just like, it's never going to have any charges or anything. It would always follow like the non-metal charges. Is that what it, or no?
Okay. Okay. It's like this.
Okay.
So the metal is positive.
Okay.
The non-metal is negative. When they get together, right, they balance each other out completely.
Yeah.
Right. So then they're totally neutral. They're not insane or anything like that. You think they're a normal couple because you have that one that's real positive and you have that one that's real negative, and they completely balance each other out.
Okay.
So when they come together, they don't have a charge. But
Okay.
independently, because you can have ions by themselves, right?
Yeah.
They're charged. Iron 3 is going to be a plus. When it's by itself, it's a hot mess. You know, it's +3, right? And then iodine is going to be minus. And so it's going to take 3 iodines to balance out that iron. Sorry. Typo there.
Yeah.
Okay, does that make sense?
Yes, it does.
Yeah. And so what you got to remember is that you always want them to balance out. That's why it's important to understand things have to balance. Opposites attract, they have to attract so they're balanced. If they don't attract so that they're balanced, they're going to bring another one on, right? To balance it out. So in this case, iron, it takes 3 iodines to balance out that iron. Okay. Do you guys get that, right? And then the number here, it doesn't refer to the number of iodines. It refers to the charge on the iron. Okay, do you guys get that?
Yes.
Yes.
Let's see, let's try one more before I throw you guys to the dogs. Let's see, let's do. Okay, you guys see it?
Yeah.
Okay. So, what is that looking like?
Confusion. I'm just kidding. So I know we have copper.
Copper.
Mm-hmm.
Copper.
For sulfur and oxygen.
Okay.
Is it copper sulfide?
Nope. Because ide means that it's all by itself.
Oh.
Is it all by itself? Is sulfur all by itself?
Is it oxide? Because it's the 2 applies for right or no?
Nope. So why in the hell did you learn polyatomic ions? Why did we talk about that?
Yeah.
Why? Why?
Why do we talk about them?
Yeah, why do we talk about polyatomic ions?
Because they're important.
Because they're important and we should probably use them, right?
Yeah.
So if we look on our table, do we have SO4?
Oh, yes, we do.
Oh, we do have SO4, right? What is the charge on SO4?
SO4, it's a 2 negative.
It's a 2 negative. Okay, so we have sulfate, right? Isn't that what that's called?
Mm-hmm.
Right? So if I have SO5, I'm going to assume it's going to be the same, right?
Yeah.
What is that going to call?
What is that? What I'm sorry?
The one with SO5. So this guy is called sulfate. What is the guy above it called? Can you guys see above it?
Sulfate?
Persulfate. That is correct. So we know that we have persulfate.
Yeah.
Right? So anytime that you have a metal and nonmetals, you should immediately know that it's an ionic compound, right? That is the first thing that you see. Do we have a metal and a nonmetal?
Metal or non-metal?
Do we have a metal and a nonmetal? Now, come on, you guys should be able to tell me if I have a metal or non-metal. There are 22 of you guys. I hear one person. So here in this compound that I wrote down here, CSO5.
So you have an
The SO is a non-metal,
yeah.
So SO are nonmetals, right?
and then the copper is a metal.
And copper is a metal. So we have a metal and a nonmetal. As soon as I see that, what do I tell myself? What type of bond am I going to have?
You're gonna have a
Ionic.
ionic bond.
Ionic bond,
Yeah.
right?
Yeah.
So that was all that was stuff that we learned before, right? So don't forget any of the stuff that you learned before because it all plays a part. So we know that we have an ionic bond, right?
Yeah.
So
Yeah.
then we also means we know that SO4, well, those are two nonmetals that are together. So that probably means that they're a polyatomic ion because we know that the copper has to be charged.
Yeah.
Positively charged, right? And so that should tell me immediately, hey, polyatomic ion. Let me go to my polyatomic ion sheet. Doesn't that make sense?
Yeah. It does.
Okay.
Okay. So when you guys come to class, I didn't print it out because I'm cute and cuddly. I printed it out because you needed it, right? So
Yeah.
you have a periodic table and you have a polyatomic ion sheet. You guys see that?
Yeah.
Okay. That should be, you know, you guys don't bring, I don't make you bring a book. You should bring this. This is kind of like your Bible here, right?
Yeah.
Okay. So when you go to church, don't you bring a Bible?
Mm-hmm.
Really?
Atheists, look at you.
Yes.
Okay. So you want to bring this every time. This is church, right? Chemistry is like church. This is your Bible for this church, okay?
Does
So
the app count?
what was that?
I said, does the Bible app count?
The Bible app. Yeah. Okay. So now that we know that we're working with persulfate, right? Now we need to figure out what copper is it. What copper is this going to be? Because isn't copper a transitional metal?
Yes.
Okay. So what does that mean? Immediately you should say, oh, transitional metal. I've got to tell it who it is. Who is it?
Transitional metal.
So we know it's a transitional metal. So we need to give it a Roman numeral.
Yes.
What was that?
The,
Transition.
copper 2.
Is it copper
Eh?
2? So how many of these?
5? Oh, wait, 1?
So we have to, so is it better if we try to balance it out, right? Because copper will follow sulfide, right? Or
You mean
sulf-
persulfate? Yes,
Sulfate.
that's right. So we got to balance it out. So how are we going to balance it out?
So we're gonna
Right.
add 2 of the copper, right? Because we
What was
have,
that?
are we gonna add 2 of the copper?
You tell me. Right now, how many coppers do we have here?
Just-
According to my chemical equation.
Just one.
So would I add 2 coppers?
No, you would add 5.
I would add 5 coppers?
Would you add one more copper?
Okay, this is the chemical equation. It tells you how many coppers there are. How many coppers are there?
One.
Okay, so let's not regress, right? You guys know that the subscript tells me how many I have. If there's no subscript, we know that there's how many coppers?
1.
1. We have 1 copper. Okay,
Yeah.
how many sulfates? How many persulfates do we have?
2.
We have 2 persulfates. what is the charge on each persulfate?
2 minus would be 4. right?
-2.
Oh.
Okay, right? So each one is 2 minus, right? So this is what we're saying. Right now, this is what we have. We have SO5, 2 minus, SO5, 2 minus, right? And we have 1 copper. So what is
Yeah.
the charge on that copper? Big question mark. Tell me what it is. Question mark. What does that copper have to be for it to be balanced to 0?
-4.
2 minus 2
2 plus.
2 plus
4 plus.
Boy, okay, you guys are worrying me now. I'm like, I'm going to pass out. Maybe it's the.
Is it -4?
Or what? What was that?
-4?
Okay, now I'm going to ask you something. Okay, let's say it's -4, just for the hell of it, right? So you're telling me that this is 4 negative. Now I want you to do the math. So if I have a -4 plus a -4, does that equal 0?
No.
Nah.
Man, it's amazing, right? So we know that doesn't equal 0. So then what must copper be? And can
Four.
a metal ever be negative?
A 4 plus.
It is 4 plus. So we know that a metal is going to be positive, right? First thing, okay, unless it's a metalloid, because metalloids are kind of weird. Okay, we know the metal's going to be positive, so we don't want to ever put a negative behind it because that means it's lost. I mean that you're gaining electrons. We know that metals want to lose electrons, right? You guys remember that, right? All the stuff that you learned before, right?
Mhm.
yeah
Okay. So we know that this is a +4, right?
Yeah.
4 plus. Okay, so let's just do the math just to be sure. 4 minus 4,
0.
0, right? Doesn't that
Yeah.
make sense?
Yeah.
Yeah.
So why is it that we're having such a hard time with addition?
For me, it was the 5 that like messed.
Yeah.
Okay, so I threw you off with the persulfate, right? Again, something that we talked about that you guys got to keep it going, right? So this is, okay. How do I say this? I don't want to get too carried away. I'm going to let you do what you need to do first, and then I'll get carried away because I have to do this early, right? You guys got to remember one thing. This is a class, right? You want to come to class prepared. You want to come ready to learn, ready to bring stuff in. That means that you got to remember what you did last and the time before that and the time before that. And if you're not remembering, you need to look over it. Are you guys doing that?
Yeah.
Or you will after today, right?
I have my notes that I look through.
Yeah, and that's what you're supposed to do. You're supposed to be looking through your notes, right? Kind of brush up your memory. Okay.
Don't get mad at me. Because
I promise I will try not to get mad at you.
I know because what we're doing is balancing it out just to make sure that we have, that it's 0.
Yep.
So I know that we're adding the 4 plus because we want to make sure that 4 minus 4 equals 0.
Yep.
Are we doing this? Are we so it's okay to add on in like say like theoretically speaking, it was like the persulfate had like a 5, so it was like 2 5 minus 2 5 minus I'm sorry 5 -5 -5. So that means that we would still add for copper, it would be like a +5 to balance it out, right? I'm just throwing it out there, kind of like that, or no?
Okay, so you're basically saying if we didn't have, let's say we had phosphate here instead, and we know that phosphate is what charge?
3 plus.
3 minus.
3
Okay, so we know that phosphate is 3 minus, right?
Yes.
Okay, so now that we know that phosphate is 3 minus,
Yes.
so what is going to be the charge on the copper now?
+3, right?
Is it going to be +3? How many of phosphates do I have?
Oh no, never mind. We have 2.
Mm-hmm.
So
Then what is it going to be?
So it's going to be basically the same thing, right? It'd be
Positives.
no, it would be
Positive.
no, it would be just 2, right? Plus
Let me clear off a board here. So everybody's got their computer on the table. Everybody got it handy right now?
Yeah.
Mhm.
Good. So let's go to a whiteboard because like this is crazy.
I can't see.
So it's gonna be the same thing. It's gonna be a +4.
All right, you want to put money on that? I'm willing to bet you guys $1,000 each that it ain't going to be +4.
I'll give you a gift card.
Because phosphorus is a -2 and you have 2 of those, so that's
Oh.
4.
Okay, so what did you just say?
You have 2 of the phosphorus and each one is a
And you told me that phosphorus is a what charge?
-2.
Do you want to put money on that?
It's 3. I said
-3.
Okay, so let's do a comparison here, right? So we have copper.
Yeah.
Copper. Okay, so copper per sulfate, we know the copper was a +4 charge, right?
Yeah.
Okay,
put this away.
now
Hurry.
copper phosphate is going to be, okay, so copper phosphate, what is going to be the charge on this copper? So you just told me, Daisy, what is the charge on phosphate?
-2.
3.
No, it's 3.
Daisy.
I didn't say -3. I said -2. So whoever
But-
said -3 was.
But you looked on, you just looked on your polyatomic ion table that you have available right next to you, right?
Oh, I looked at the periodic table. So you want
Ah. And even on the periodic table, where is phosphorus in the first place?
it's on group 1.
Second line.
Oh, you know
Okay,
what?
now wait, Heather,
Periods and
where?
group.
Because I don't know what the second line means. What the hell is that? That's not chemistry. The second what?
Period 3.
Yeah.
So it's
Group
period
5.
3,
Group
and
five.
then group what?
5.
Group 5?
Sorry, I was looking at the wrong one. I was looking because I was looking at PO and then I was looking at the polonium.
Oh, okay.
Sorry. So yes, it is a -3 charge. So your copper is going to be a +6.
Okay, but we also know that phosphate is different than just polonium, right? Phosphate, PO4, right, is a polyatomic ion. It
Yeah.
has a charge associated with it. It just
Yeah.
happens to be,
Mhm.
well, it doesn't just happen to be. For a reason, it has the same charge as phosphorus. So we know that this guy is a -3, right?
Yeah. Mm-hmm.
Mm-hmm.
You guys said, what group was phosphorus again?
5.
Group,
Group 5,
group 15.
group 15.
15. Sorry.
Yeah.
Okay, now you guys need to remember that stuff, right? That's things that you learned the first week of class, right? You
Yeah.
can't forget that stuff. Okay. So we have 2 of these guys.
Mm-hmm.
Okay, now you guys tell me, how many coppers do I have?
You have
1. You
1.
have 1 copper.
I have 1 copper. Okay, and what is the charge on that copper?
+6.
6 positive.
You said 6 positive, okay? Oops. 6 plus. Okay, so what is the name of this compound?
It's going to be
Would it be copper, parentheses,
Copper,
Roman numeral 6,
phosphate.
Mm.
Oh, it's a 6. Hold on. It would be
Copper,
Roman numeral 6.
yeah,
6.
Number 6.
and it's a phosphate.
Okay, good job.
Okay. Thank you.
Okay, so we know that it depends on who it's with. You can't just assume because it's copper, it's always going to be the same. Remember, transitional metals are hot messes, so it just depends on who they're with, right? If they're with an asshole, they're going to be like an asshole, right? They have to balance out the asshole, okay? If they're with a sweet guy, then they'll have to try to balance out the sweet guy, okay?
I get it now that you write it out like that over each other because I was getting confused.
Okay, so is that better?
Yeah,
Okay.
way better.
Do you feel you got a grasp on things?
Yes.
Mhm.
Okay. Are you guys ready to prove it? Because it don't mean nothing until you prove it, right?
Yeah.
Okay. Okay. I just want to be sure. Okay, so we're gonna pull up something. Let me see if I can find it. Let's see, what is today? No, that's today. Oh, not that one. Come on. Sorry, my computer's running a little slow today. Come on. Man, it is struggling right now. Give me 1 second. I'm trying to figure out. Can you guys hear me?
Yeah.
Yeah. It was lagging earlier, like when you were talking, it was skipping a lot.
Okay. So what I want you guys to do, can you guys see those questions there?
Mm-hmm.
Okay, so this guy is worth some extra credit points, right? So I'm going to put you guys in groups. So what I like you guys to do is go, as many of you guys that can, or take a screenshot of it. Take a, you can also go to annotate, hit save, and then go to Finder, and then it'll be shown up on Finder. So I want you guys all to do that right now. Everybody did it?
I just wrote them.
Yes.
Okay, you got it? Everybody got it. So I'm going to put you guys in groups. Okay, so the group that has the most of them that are correct, right? And you've got to complete it. If you don't complete it, you have 20 minutes to complete it. If you don't complete it, you don't even compete, right? And it's the team that has the most correct will get the points. Okay? Are you guys ready?
Yeah. Hold on 1 minute. I'm trying to cook and grab my stuff at the same time.
So we're doing 10 in total, right? Or just like the ones that are in red? Or
There's 10 in total. So there's that first that in red, and then you have the ones down here. I rewrote them, what they actually look like. So this is the
What?
So do you guys see the ones down here? The black ones? Or in the pink ones?
Yes.
The pink one is the same thing as the black ones, but they're written the correct way in pink. Right? Because if you notice, there's no subscripts because we can't type in subscripts.
Okay.
Okay. Are you feeling competitive?
Yeah.
Okay, good.
Nervous.
Okay, so let's see options. And okay, so now I'm going to ask you a question and be honest. So somebody take the poop on your porch, right? Then you notice next day somebody else takes a poop on your porch. Okay. Now you've noticed this person been taking a poop on your porch every day. So you decide that you're gonna watch and figure out who's taking a poop on your porch. So you go one day and you notice, you go in the house, there's no poop on your porch, and later on, there's poops on your porch. Okay? And you see this guy walking away. Now the first day, you're like, okay, maybe it's not him, you know? So next day, you notice no poop on your porch. A few minutes later, there's poop on your porch, and you see this guy walking away. What is your conclusion?
He doesn't like me.
Well, obviously, he's pooping on your porch. That's clear, right? But is that the guy that's taking a poop on your porch?
Yeah,
How did you figure that out?
because I was watching him.
No.
You watched him leave, right? But you paid attention to those details, those little details. I had no poop on my porch, and now I have poop on my porch, right?
Yeah.
So I made observations about things that are going on. Now I'm going to ask you something. You guys
Can someone turn their
crazy.
TV off?
Yeah, I can't hear.
Can you guys see my whiteboard? I.
Yes.
Now look at this. This word IDE. I. Okay. We have sodium chloride. Have you guys seen that before? What is sodium chloride?
Salt.
NaCl.
And we know that it's NaCl.
Yeah.
Okay. We have carbon dioxide. Does that also have the I at the end? IDE?
yes, it does. Yes.
Okay. I have carbon monoxide. You guys heard of all those before, right? Before you even came to chemistry, you've heard of those before.
Yes.
Doesn't that have an IDE in it? This one is CO. This guy is CO2.
Mhm.
So now if I was a Betty man, right? And I had this word, nitride, or this word, phosphide. What would I assume would be the symbol for that?
It would be PO, right?
Now, pay attention. Do you see an O up here for sodium chloride?
No.
I'm sorry.
No.
No. I was
Okay.
looking at something. Oh, I didn't know you could hear me.
Oh, I have really good ears.
No, I'm sorry. I was talking to myself.
Okay. So I noticed that there's only an oxygen here. I know that there's only an oxygen here, and I know there's only a chlorine here. So what would I assume these symbols are for these two? Because I'm constantly giving these. I've seen all of these before. I can sit there and use the stuff that I've learned, that I've noticed that this person is pooping on my lawn, you know? I can sit there and make that assumption, right? So what would I assume the symbol is for this?
All of them have a negative charge.
They have a negative charge, okay? That is one thing that I could probably assume, right? Probably, because it depends on who they're with, right? But what is the thing that I noticed? Where are they located? Are they at the beginning? What was that?
They're located on the oxygens. So
Are they located? Because sodium chloride is not located on the oxygen. The iode is not on the oxygen.
On
They're
the
non-metals.
nonmetals.
They're located on the nonmetals, right? And if you notice, right, in this case, but this is also carbon here, it doesn't have one. Why doesn't it have one?
Why doesn't what have one? I'm sorry.
Carbon. Isn't carbon a nonmetal?
Yes, but it's a -4 charge, right?
Okay.
Uh-huh.
Tell me about this. Is this a covalent bond or is this an ionic bond?
It's an ionic bond.
Are you sure?
No,
that's a covalent because it's between non-metals.
Okay. So when we have two nonmetals together, they form a covalent bond. So we know two nonmetals together form a covalent bond because we learned that last time. And we need to remember what we've learned the last time. Are you guys with me right now?
Yes.
Okay, so I'm going to ask you one more time. Okay, one more time. What would be the symbol for this guy? Is it going to be Z, X, Y, F? What is the symbol?
P.
Okay, so we know that this guy is going to be just P. It's not going to be PO. It's not going to be PO12 or PO4 or PO3 because we know that IDE is only for the single element. This is for chlorine. So chlorine becomes chloride because it's in a compound, okay? Oxygen becomes oxide because it's in a compound. Oxygen becomes monoxide because it's in a compound. When we're talking about covalently bonded, we have to tell me the number, right? Yeah. So covalent bonds, so anytime that you see di, right? Mono, tri, tetra, and stuff, right? That tells me that I have what type of bond going on there?
What was the question again, Dr. Harry?
I said that tells me what type of bond do I have. If I see mono oxide, dioxide.
Covalent.
That's still a covalent.
Can you repeat, please? You said covalent, right?
Covalent.
So
Yes.
it means that it's covalent bonds, right? So I know that I only use that with covalent bonds, and covalent bonds only occur between metals.
Non-metals.
Non-metals. That's right. Non-metals. Okay. So if I have a metal and a non-metal, then what type of bond is that?
Ionic bond.
It's an ionic bond. Ammonium is our exception, right? Because we know ammonium is set of polyatomic ions, right?
Yes.
NH4, Cl, right? So ammonium chloride, right? We know that this is an exception, okay? So my point is this, right? And this is the thing that I'm realizing, right? So you guys go through the motion, right? You come here, you're like, okay, I'm gonna come to chemistry class. You're not coming in with your Bible, right? So that means you're not ready for chemistry, right? You're not thinking about the process, right? You're not thinking about whether it's covalent or ionic because, hey, that was something that we learned last time. So I'm just gonna pretend like I didn't even see it and ignore it completely, right? That whole concept. We know that covalent means sharing, right? It's sharing of electrons. We know that ionic is about give and take. That means charges, right?
Yeah.
Okay, so when I'm balancing out charges, am I doing covalent bonds?
No.
No, you're
No,
not.
because they're sharing, right? So you want to sit there and think about the stuff that you've learned and start applying it. Because if you're not doing that, you're not learning the new material. You're struggling. You're falling behind, right? Okay, so let me see your answers. So did you guys submit?
I tried to submit it. It's not letting me submit it. It's saying network something error.
Yeah, I can't
It
submit.
says
mine.
network disconnect resend.
Irritating me.
Okay, so do me a favor, just email it to me.
Okay,
Okay, so, and I'll give the points to whoever.
forget
wins.
about it.
How do we know? Where
in
we
the
know
chat.
all the points? Will you let us know on Tuesday when we come back?
Yeah, I'll let you know on Tuesday when we come back. You'll see points in your thing, so
Okay.
I'll do it right after this.
I'll just email it to you.
Email it to me.
Are we gonna
Okay.
go over it, Dr. Henry?
What was that?
Are we gonna go over our answers?
Yes, we are. We're going to go over the answers. Yes. Okay. And the other thing is, pay attention to how things are written. You guys ever see anything written this way in terms of a chemical compound?
That was us. We caught it.
Okay. So you always want to write. It's like mimicking, right? So how did you guys learn to write?
That's cool.
I know you learned in school. I didn't say
By
when did you learn. I said how did you learn?
by watching other people doing
The
it.
same.
By watching other people. So you guys watch me every damn day. Watch chemical compounds, right? Write chemical compounds.
It's
Every
nerves.
day.
Everyone's nervous. The heat's on.
Yeah, the heat is going to be on. You guys want to pass this class. So what I'm saying is you guys got to start meeting me halfway. I am busting my balls to sit there and try to get things done for you guys. I'm sitting there. I do a lot of fighting. I try to get, I just spent, you guys know about the grant because I told you guys.
She got it. Wait.
Right? I just spent the last 3 days not sleeping to try to get some extra money for students, right? So that they don't have to worry about working or they don't have to worry about housing and stuff like that. You know?
Well, Dr. Sorry to interrupt. I figured it out. I was able to put in for group 1 already. So
Okay, good.
yeah, we got it in.
So everybody, y'all can take a look at their answers. Let's get it on mine. And then somebody else got theirs in. Diana.
I just emailed mine to you, or ours to you.
Okay. So did everybody, and you guys put your names on there, so I don't have to know. I know who's
Yes.
what, right? Okay, good. Okay. My point is that, you know, I'm doing the best I can for you, right? I am really packaging things up for you, trying to put in the boat, but I need you guys to start doing something, right? You can't just come in and expect things to happen by osmosis. If you're not looking over the notes, if you're not looking over the lecture that I just did, if you're not getting it, you need to say something. You need to participate. And I'm glad that you guys, every group, and I'll give you guys dibs, every group I went to, you guys were talking, right? And you guys all submitted something, right? You all made an attempt to try to do something. And that I'm very proud. I can't say the same thing for the class before, right? So I'm proud in that way. But I want you guys to be successful. I want you guys to be not only successful in my class, I want you to be successful in all your classes. You guys need to start paying attention to what's going on, right? Like I mean, look at it. You've come across sodium chloride thousands of times. You came across carbon dioxide thousands of times, right? You came across carbon monoxide thousands of times. Now start applying what you learned about them, right? We know that carbon and oxygens are both nonmetals, right? So we know that when we're naming nonmetals that are together, they're going to have that di and that tri and that, you know, that prefix, right? That Greek prefix. But we also know that with sodium chloride, we don't put anything because I've told you that. And if you start thinking about anything else, right? So let's start talking about these problems here. Pull it up. And I want you guys to think before you answer, okay? So this first one, sodium phosphate. So we know immediately when we see ATE, as soon as we see ATE, we know, oh shit, that one has oxygen in it. So now the question is, how many oxygens does it have in it, right? And the way that I know that is because I know I have my polyatomic ion sheet. Do you guys have your polyatomic ion sheet?
Yes, it has 4.
It has 4, right? So it has 4 oxygens, right? So we have PO4. What is the charge associated with it?
It's
Christy, I just got yours. What was that?
-3.
It has a -3 charge. Okay, so we know that we're working with the -3 charge. So then what is the charge on sodium? What is sodium? What is the chemical symbol for sodium?
1 plus.
Na.
Na.
Na plus, I heard. Okay, so if Na is 1 plus and phosphate is 3 minus, how many Nas do I need to balance it out?
You need 2.
2.
Okay, so you're telling me if I just have 2 sodium.
Well, you need 3 in total, right?
Okay, so then you want to tell me what I need in total because I'm just going to write down what you told me, right?
Yeah, I meant to say 2 because all you do is need 2 in order to get 3.
Okay, so I need a total of 3. So
Yeah.
then when I write the chemical formula, it should be Na.
Na3PO4.
Na3
PO4.
PO4.
And how many of you guys got that?
Group 2 got that.
We got that one.
와인컵도 톡스코 두 번. 그럼 괜.
Oops. Okay. Number 2. Iridium for nitride. Ooh, it has IDE. What does that mean?
Just going to be an N by itself, nitrate.
Okay. You mean nitride, right?
Nitrite, yes,
Yeah.
sorry, nitrite.
Okay.
So IR,
Okay.
and 4.
Is that correct?
I don't know.
No, it should be IR3.
IR3, right? So we know that iridium has what charge associated with it?
It's gonna have a 3.
It's going to have a what?
-3? A +3?
It's going to have a what?
A 4.
A 4. I'm sorry.
Okay. So we know that the Roman numeral means the charge on that metal. Because Dr. Henry taught me that 6 times already.
Yes, you did.
So
Okay.
it would just be IR. 1, 2,
Or
3.
technically it's IR4. So the answer is, this is the answer, but I'm showing you how you get to the answer.
Oh, okay, okay.
Okay, so that's why I break it down so you guys can actually see it, right? Because seeing is believing, because as much as I say it, you don't want to listen to me. Stop listening since spring break. And what is the charge on nitrogen?
Nitrogen is 3. 3 negative. -3, I mean.
Okay, so I want somebody to add up all my negative charges.
That's 4, right?
There's 4 of them. How many? So add them all up.
-12.
So that's 12, so that's -12.
So it's -12, and then add up all my positive charges.
Positive 12.
Okay, does that equal 0?
Yep. Okay.
Okay, so that means that we obeyed the rule that we were taught, right?
Yes.
It
Yeah.
has to be neutral, has to be 0. Okay? Tungsten. Tungsten 5 hyposulfite octahydrate.
Well, tungsten W.
I'm going to erase this stuff up here to give us a little more room to work. Drag this
That
over.
one, I'll be honest, we did have a hard time with.
Okay, that's fair. So let's break it down.
So tungsten, we know it was W,
Okay, so we know it's a W.
and the charge is 5.
The charge is 5. Good job.
And then I was a little confused with the hyposulfite.
Okay,
I know-
so hyposulfite, what does that look like? What does the
That's an
chemical formula
oxygen,
look like?
right?
What was that?
Does it have an oxygen?
It does have an oxygen. That's good.
We're
How many
learning.
oxygens?
It has 2.
It has 2. So it's
SO2.
SO2. And what's the charge on it?
It's it's
2 minus.
yeah.
It's 2 minus. Kichu, go ahead. Somebody is stepping up. Okay. SO2, 2 minus. Okay, so we have this guy is a 2 minus. So if I want to make this 0, how many tungstens do I need? And how many sulfates do I need?
You need 5 of the sulfates.
I need 5 of the sulfates. Hyposulfates, sorry.
Sulfates.
Sulfites.
Mhm.
Somebody sniffling? It's okay. Don't cry.
He's crying.
It'll be okay. Okay. So, and then how many tungstens?
Tungstens, it's gonna stay the way it is because we already have 5, right?
Okay, so you're telling me, and I want you
No,
to.
you need 2 because 5
need-
plus 5 is 10.
Okay, there we go.
I have to add them. Sorry. Thank
Okay,
you.
so that's 10 minus 2, 4, 6, 8, 10, right?
Mm-hmm.
So then my answer should be,
0.
it should add up to 0. So, but it's W2 parenthesis SO2 5. Now, octahydrate, what does that mean?
It needs 8.
8 H2Os.
8 H2O.
That's right, 8 H2Os, that's right. Because when you say that word hydrate, that means water.
Oh, we knew that part.
Confused on the hyposulfite.
Yeah, we were confused on the hypo.
So you guys just remember, if you start off with sulfate, then you go down to sulfite. So that's SO3, 2 minus. And then you go hyposulfite underneath that one. That's SO2, 2 minus. Okay. Okay, what about the next one?
The next one is gonna be SR.
Okay. SR.
And that's gonna be a 2 plus for that one.
Okay. What about perarsenate?
Is it gonna be
ASO5 3 minus.
Oh. ASO5, 3 minus. You want to tell them how you got that?
I just wrote like a cheat sheet. Like first it's per, then it's 8, then I, then hypo, then I'd. So I kind of just went wherever it was. So it was 8, and I just added one.
Right.
I don't know how to
Okay.
explain it. I was trying to
Yeah,
show my
no,
group. but-
that's fine. You did a good
Okay.
job. Okay, so how many per arsenate do I need to balance out the strontium ion?
In total, you need 2.
Okay. And then strontium?
You need 3?
No, you need 2 in total.
3 in total.
3.
That's 2, 4, 6 positive charges. 3 plus 3, that's 6 negative charges. That equals 0. So then, what am I writing?
Sorry, 3.
SI 3.
It's going to be a parentheses, and it's going to be AS05. Close the parentheses and 2.
Okay. What about this guy?
Ugh.
Diphosphorus, dodeca sulfate, pentachloride.
That's the one I have trouble with. I know di means 2.
Okay.
Phosphorus is
Two?
phosphate.
P.
So it's going to be P2, right?
That's right. P2.
Mm-hmm.
Dodeca would be 10.
That's 12.
It's
It's-
12.
Dodeca is 12.
Sorry.
So
We're learning.
That's 12.
S12
L5.
and Cl5. Okay. Now, again, I'm going to stress, you guys know that you always start with the element and then the subscript to tell me how many I have. The element and the subscript to tell me how many I have. That makes sense?
Yeah.
Yeah. The only time that you put numbers in front of here is if you're talking about coefficients. And that means you're balancing equations. Okay. Now, what about this guy? Number 1 down here. Black.
Magnesium dichloride.
Oh, wait. Did you say di? What is the rule?
You have to put the Roman numerals.
Do I have to put wrong? So you're telling me that magnesium is a transitional metal?
Oh, no, it's not.
No.
Oh,
Don't listen to me.
So it would just be magnesium chloride.
Right?
it would just be magnesium chloride.
Okay.
When ours, just ignore the di.
Now, when you try to administer that, then somebody say, what the hell is this? Right?
Yeah.
Okay, this guy. N5O4F3.
We put penta nitrogen. Will that be correct? Penta,
Penta,
nitrogen, tetra, oxygen trifluoride.
Mm.
Oops. That is correct. Okay.
And then the other one was calcium sulfide.
Okay.
Chromium dioxide. I don't know. That one looks like
Is it chromium parentheses IV oxide?
That is correct.
oh, we forgot the parentheses.
Chromium,
Roman
IV,
numerals.
Because that was,
IV, and we don't use di for,
yes, for metals.
Yeah.
okay.
Okay, so that one we had wrong. Okay.
The last one was silver nitride.
Silver
Nitrite.
nitride.
Nitride. Sorry.
Okay. And why don't we use a Roman numeral here?
Because it's not a metal.
Silver's not a metal?
And because it's a metal.
Because it
So-
has metal.
It's a metal.
No,
But
it's a
isn't
transition.
silver? Wait.
No,
So,
isn't it because if it's an ionic?
but didn't we use a Roman numeral at the one before? Why didn't we use a Roman numeral here?
Good question.
Yeah, remind us, please.
Because we know that silver is going to be silver 1 unless, so it's always going to be silver 1 unless we're told otherwise, right? So here we know that this is actually silver 1. So it's understood to be silver 1. So in this case, it is only for silver. Silver is a special case. So silver 1 is always going to be written as just silver. But if it's silver 2, then we have to write silver 2. You understand?
I'm sorry to interrupt, Dr. Henry. So is it similar to iron then? Kind of?
No,
No?
iron is different. Iron has, okay, so you're caught up on that iron thing, aren't you? Right? So-
Honestly, I haven't finished Tuesday's lecture. I'm working on it right now, so I
Yeah.
just want to make sure I have it correct.
Okay, so transitional metals always need a Roman numeral, but there are a few transitional metals that, because the way they work, the way that they are, there's only ones that exist in nature the majority of the time.
Okay.
Right? So for instance, silver 1 ion is the one that exists 99.9% of the time. The only time that you don't have silver 1 is if a chemist does something crazy and makes it crazy. Okay?
Okay. Are you the crazy chemist?
Yeah, I've done it before.
Yeah.
Okay. Are you guys good? You guys understand that?
Yeah, but can we do like this another time, like try it again next Tuesday, like as a practice so we could get it more?
Yeah.
But that's why you have 109 homework assignments.
I mean, I started, but I feel like in a group, it kind of like we help each other with the ones that we don't understand.
Exactly. In a
Yeah.
group. So that means that you guys need to reach out to each other. And you guys can actually, you guys know that you have access to Zoom, right?
Yeah, but it's hard because say like there's some students, because I'm a Coalinga student, and there's how like you have another
Oh, so that means that you guys should exchange numbers or go on Remind and talk to each other on Remind, because you guys know you can do that as well too. That's the reason why.
what is that? I've never heard of that. I'm sorry.
It's the app that I told you guys to download and at the very, very beginning when we talked about the syllabus. If you go to my syllabus and you clicked on direct messaging, DM me, right? It'll take you to Remind, and so you guys could communicate that way as well. Or you could guys give each other's number, and you guys can just text each other.
Okay.
Or I'm sure that you guys probably have Snapchat or WhatsApp or
On that homework, I have 100 out of 108 already.
you've done 100 out of 108.
Yeah,
Look at you. Go ahead, and you can
I
tell because you seem to have a good grasp on it.
I just need like 8 more, but on 2 of them, I don't have no more chances.
I extended some of your chances.
Okay,
It should be good.
thank you.
You're welcome. Okay. Are there any questions? Okay, good. So overall, you guys, this group is doing pretty good overall, but I want you to do better because I want to see some A's, right? You guys want A's, right?
Yes, we want A's. A's
Yes.
only.
Your next exam, and again, this is your bread and butter. If you cannot name chemical compounds, you're going to fail chemistry. So you want to make sure that you get this and you understand it and you don't make the little mistakes. Okay?
Okay.
Okay.
Got it.
So do the homeworks, do the practice tests, Did somebody there's Deanna's number in the chat window. Okay, any questions? Concerns?